Okay, at this point we've spent a good deal of time discussing what classes were as well as class members, talking about fields, methods, and properties. Now what I'd like to do is take everything that we've learned and apply it to a very simple application. We're going to stay outside the world of a Windows app or an XNA app. We're going to make a very simple console application demonstrating the whole concept of simple object-oriented programming. The idea is we want to have a class that we're going to be able to instantiate from. We want to be able to have some very simple data members, some properties, and some methods. We'd like to be able to simply create an object and then let that object basically handle itself. So what we're going to do is create an application that we're calling bouncing X's, because we're going to start out by simply having the character X bounce around the screen. More or less, it's like the box application that we did back in Volume 1, where we had a box that bounced around the screen, which ended up being a button. So same type concept, but by doing this outside the world of XNA, and outside the world of a WinForms application, we're able to focus solely on the whole object-oriented nature of what's going on without a whole bunch of other stuff getting in the way. And that's the goal of the lesson, just to make this as clear as possible. So again, what we're looking for is to be able to create a very simple console application. So here's our console. You guys have seen me draw the console probably 100 times. We're going to have an X character, and we'll be able to give it a color and everything, and give it a velocity, and once we do, it'll handle itself, and it'll simply just bounce around the screen. So we're going to use very simple bounce code that we've seen in the past, and yeah, something like this right here, and he just keeps on going and has a good time. The idea, though, is once we've gone through the creation of this very simple object-oriented programming, we're then going to turn around and we're going to introduce you to lists, and then we're going to come and revisit this application, and we're going to make it such that we can add a whole bunch of these guys in there. And the convenient thing is we're basically giving them behavior, as we've discussed, one of the nice things about object-oriented programming, and with them having their own encapsulated behavior and data, we can set them off and just let them do their own thing, and we don't have to worry about going into every single one and handling, what needs to be done in order to update their position on. They can take care of themselves. That's the benefit of this here. So we're going to create, we'll call the class box, okay, instead of X, because X will look kind of funny for instantiating and all that good stuff. So we'll create a class box, so you can visualize this as a box if you want. Just know it's going to be represented with the character X to start out with. And inside of the class, we're going to, of course, need to have some fields, because that is one of the things we've talked about. So what kind of fields are we going to have? Well, we're going to have a private position. And position is going to be of type point. So where do we want to get point from? Well, of course, we could get it from drawing, but let's get it from XNA. Let's just get you guys used to seeing XNA more and more. So we'll actually reference the XNA framework in just a few minutes. So private position, how about a private velocity? And then a color, so a private color. So that'll let you guys see something new. All right, so that gives us our fields, and then we're going to need some properties. And for our properties, we'll, of course, come in here with, and these are going to all be public, so I'm not even going to write anything next to it in regard to an accessor modifier. Blech, I suddenly forgot modifiers. So anyways, what we're going to do is have a position, a velocity. That's the cool thing, Logan, about doing all of our videos unscripted. Sometimes you just simply forget what it is you're going to say. And, of course, color. Okay, so this way we will be able to access all of our fields. Finally, we need to give some behavior to the class itself. So we're going to need some methods. And the methods that we're going to add are going to be simple. We're going to have update. We're going to need to have a draw. And you'll notice I haven't put any accessors, any access modifiers in front of these, meaning we'll leave these as public. And then we're going to do a private check wall collision. Because think about it. We want to be able to call update, and we want to be able to call draw externally. But we don't want to be able to call check wall collision. We want the object itself to worry about checking the wall collision. We want to worry about as little as possible with the objects once they're born.
Yeah, what it comes down to is we don't have a separate collision checking system that we can apply to any scenario here. So we're just going to let these individual boxes check collision for themselves.
You got it. Now, at this point, as Logan goes through coding this app, way back in Volume 1, I said just watch, and if a lot of it doesn't make sense, that's okay. Please follow along. Well, at this point, most of what you see should make sense. If you're having any problems with anything that's being typed out, you may need to go back and review some of the videos up to this point. Now, there are a couple tricky things we're going to do, very small little things, because we are making something that's going to bounce around a console application, so that's interesting in itself. But just keep in mind, for the most part, 99% of all the code that you see should be crystal clear. Okay, so Logan, with that, let's go ahead and jump over into Visual Studio.
All right, let's get started.
And start a new console application.
All right, new application. We've got a console application, and that's good. So inside of our new application, you had mentioned that we're going to be using the point data type, and the one that we want to use is actually in the XNA framework. So before I begin on anything code-wise, I'm going to add a reference to the XNA framework assembly itself so that we have access to that point data type. So I'll go to References, add a reference. Then inside of References on the .NET tab, I'm going to jump down to we have the Microsoft section, and the one I'm going to grab is simply Microsoft.xna.framework. So I'll hit OK to add that in as a reference, and now we can begin on the box class. Just to keep with the standard we've been doing so far, I'm actually going to add a folder for classes, even though we only have one. But inside of that folder, I'm going to add a new item, and this is going to be our box class. So this will be box.cs. And inside of here, a few things we can clean up are, to begin with, we'll take off classes from the namespace, so we're simply in the namespace for the console application. Second, we don't need system.text at all. And third, I'm going to put in a using for Microsoft.framework.xna, and that way we'll have the point data type available to us.
Okay.
We've added the reference, but I'm also going to add the namespace and a using so we can directly access point.
Without having to type all of this stuff out that you're about to type now.
Right. So I'll add in a using for Microsoft.xna.framework. Alright, that takes care of a little bit of cleanup. Now we can begin on the box class itself. The first thing we'll add in is our private fields. So this will begin with our points for position and velocity. So we've got a private point position and a private point velocity. Alright, and then the third thing that we have is the color. What is the color of this box? This will be a, again, private field, so private. Now the data type here is going to be console color, because we're going to be writing things to the console, and that's simply how you tell the console what color you're going to use. So this is going to be of type console, console color. And it is going to be called color. Alright, that takes care of our fields, and now we need to put in some properties. I'm going to define a region just so I can collapse these down later. And this will be the region for our properties. And then we'll end off the region. Alright, first property is going to be for position. This is going to be a public property of type point, because we're going to use it to access position, and it's going to be called position in, point. Position. And it's going to have both a get and set accessor, so it's both read and write. The get is simply going to return our position, and set is going to set the position to the value for this property. Alright. All that looks good. I'm going to quickly build to make sure I haven't introduced any syntax errors so that I know that this property has been defined correctly. That way I can copy the property and then paste it in a few times to save time. So there is the property pasted twice. So we have position. We also have a point for velocity. So I'll make the property velocity. And we want this to be used to access the velocity field. And finally we have a console color for color. So for this property, course, want its data type to be console color, and its name to be color, and it will be used to access the color field.
So again, just got to follow along with Logan. He's just doing a bunch of copy and pasting to save time.
And with that, I think that takes care of our properties.
Yep,
so to save on space, let me collapse down this region. As a matter of fact, let me build first, make sure that there's no errors in any of this.
Okay.
Now I can collapse this down, and we can move on to the methods for the box class.
Okay.
So jumping down.
Go ahead and define a region for it?
Sure. We'll define a region. I'll just call this something simple like methods.
Yeah, methods is perfect.
And off the region. All right, now let's put in our two methods. As a matter of fact, I'll just follow suit and do the skeletoning method. So we'll skeleton in update and draw before we actually implement them.
And check wall collision.
Oh yeah, that's right. We've got that too.
Yeah, we got 3. Yeah.
All right. First is going to be the update method, which is going to be public void update, and takes in no parameters. Followed by public void draw, also takes in no parameters. And finally, we have private void check wall collision, and it takes in no parameters as well. Alright, that takes care of our 3 methods. Now let's go ahead and implement them. We'll begin with update, and update is going to take our current velocity and add that to position. So, or another way to say that is position is incremented by velocity. So we'll take our position. This is just the local position field. And we'll say that the position.x is going to be incremented by velocity.x. And same with y, position.y plus equals velocity.y.
Now there's no dark magic going on here. This is really the same thing that we've demonstrated back in Volume 1 when we have something that's simply moving with a velocity. That's all. We're updating the position based off of the velocity.
All right. And if
you seem to be confused with any of this, just jump back to Volume 1 when we walked through creating the button that bounced around the screen and review that section, because we took the time to draw it out and heavily explain exactly what was happening. Same principle. Sorry about that, Logan.
Sure. All right, but after we've adjusted x and y, that means we've moved one more amount of distance in any given direction. After we move, we need to do the check to see if we have collided with a wall yet.
That's right.
So we'll run check wall collision. And that will take care of update. Again, very simple. Its purpose is just to move this box around and check for collisions. All right, now we can move on and implement draw. Draw's job is basically going to break down into 3 different things. It's going to set up the color for the console so that this box is drawn, or this X is drawn in the correct color, taking into account its own color field. Then it's going to set the position set the console's cursor position to wherever position this box needs to be drawn at, and then finally perform a simple write operation that will write out.
Which means it's going to write whatever character we have it write at the position that was just set in the statement previously.
And this is how we'll simulate individual things moving around, is to simply, just before we draw, set up the console to draw at the correct position. Alright, so let's look at some of these setup things. First, of course, all these are going to be console, and the first thing we need to look at is the foreground color of the console. So we'll be setting the console's foreground color to be whatever the current color is. So we'll just fill in the color field here. Next, we'll set up the console's cursor position. We'll do that by using the set cursor position method, which takes in a left and top. We can feed our current x and y out of our position. So that means we can feed in position.x and position.y. And that will have the console's cursor set to the position of this box. Finally, we need to write out an X. And this is the simple and probably more familiar thing. This is where we'll simply do a write. We're not doing a write line, of course, because we've already established an exact position. As a matter of fact, everything is going to have an exact position.
That's right.
So we never want to advance by another line. So in this case, we'll do a simple write, and I'll write out a literal character, capital X. Lowercase x could also work, but that should work just fine.
Okay.
And that should take care of the implementation for draw. Now we can code in check wall collision. And this is simply going to be a series of if statements to see if we have gone off screen in any of the 4 directions, up, down, left, or right.
Okay.
So let's take a look at horizontal first. Let's check the X position and see if that's within range for being on screen. We'll first check and see if position has gone below 0. So this check will be if position.x is less than 0, and I'll block this in, and we can say that if position.x has gone less than 0, the first thing we need to do is to snap the box back on screen by setting x directly to 0. And then we need to reverse the velocity in x. So we could take our velocity.x and multiply it by -1 to reverse x. And if that was the case, then we also need to do a check for if x has gone off screen to the right, or in the positive direction. So I'll throw in an else if, where we can do a check for if position.x is greater than our current console's window width. So I'll need to look at console and get the window width. Now if we draw all the way to the very edge of the screen, because of the way the word wrapping works in a console app, it could actually wrap around and then go down another line. So we need to actually give ourselves a little bit of buffer room and make sure we don't hit the very, very edge. So I'm actually going to subtract 2 from this to give enough of an offset, so that way there's never a danger of wrapping or other problems. So we'll do the check as being if x is greater than console width -2, and if that is indeed the case, then we need to set our position. So I'll set position.x, and again, if it's gone too far past our check width, set it back to the exact check width, which is console width, or console.window width -2. Now again, we need to reverse velocity, and since we've already got the code for that, I'm going to simply copy and paste that in place. Alright, that should take care of horizontal. We have horizontal going off the screen to the left and off the screen to the right. Now we need to do a check for vertical collisions. And to do that, I'm going to copy this entire block of code and change out x for y and width for height. Before I do that, though, I want to build to make sure that I don't have any errors in the code that I'm going to copy. So I'll hit F6, build, and make sure that everything is all happy. And it is. So now I can copy the code, paste it in below, and now we can use this block for vertical checking, or checking in y. So I'll do a quick run through here where I change position.y, or x to y. So for all these checks, and this is checking against 0, so there's no real width change to height there. For the above 0 check, or above console window dimension, I do need to change the window width to window height in these cases. And these position and velocity x's to position and velocity y's. And with that, I'll do one more build, make sure that everything is indeed working. And from here, everything looks good.
Yep, that right there has created a class that we can instantiate and then go in and define a velocity. We can define position, we can define a color, and we can call upon its update and draw to have it move around the screen, figure out if it's hit a wall, change its velocity, basically change its direction if it has, and there you go. But now what we need to do is use this. We need to instantiate the class. So let's go ahead and jump back over to program.
And let's write a small program to test it.
Yep.
Alright, first thing, let's jump into the main method, and let's create one of these new boxes. So let me make a variable called box to store a box in. This is going to be of type box, and it'll be called box as the identifier. And let's jump down onto another line. Of course, I could have done this all in one line if I wanted to. But we'll take box, and we'll assign that to a new box, and that will have the box created. Now we need to set it up. So let's set a velocity and a color for this box. So we'll take our box.velocity, set that to a new vector2, because that was, a point.
Yeah.
And point doesn't exist yet, so I'm going to finish typing this out, and then we'll add the using and the proper using so I can access point here.
It does exist. You would just have to type out the entire Microsoft
.xna. Yeah. So, all right, we're setting velocity to a new point. Let me also just take a quick divergence here and set up our using. For matter of fact, I feel incredibly lazy at the moment, so I'm going to jump over to.
Typed half of it out.
I already typed half of it out, but we can just do a copy and paste. I'm also going to take out text because we weren't using anything from the text namespace and just clean up our usings a little bit.
Okay.
And now we have point. Point is working well. So it takes care of velocity. Again, velocity is just being set to a point of 1 by 1. And finally, we can set up our box's color. So I'll set the color to console color dot red for the first
Notice
box.
how IntelliSense made it very easy since it understood it was working with a console color. Go ahead and show the IntelliSense one more time.
Sure. If we back this up a little, we've got console color, and there we have all of the colors that we could use in the case of a console color. So basically a 16-color palette is available to be used.
Okay.
And I'd set this first one to red.
All right. Let's just make one to begin with. Now let's jump down to our loop.
All right. Now we want to set up something like a micro game loop to try this out. To do this, I'm actually going to make it an infinite loop, since we know that in a console app we can just close it out. So I'm not actually giving any true way to exit it. I'm just allowing it to be force closed. Again, this is more. I'm looking at this more of just a small test app to make sure that our box class is working. So we could set up an infinite loop as our game loop, and inside of this loop, let's tell our box to first update. So we take into our account our velocity and move around. And after we update and establish a new location, we'll tell it to draw. So you should see a box drawn on screen.
Yeah, and we'll start out with just these two things, because it's not going to give us exactly what we're picturing at first. But the key thing is, now I know that some of you guys still may be wondering, why exactly are we taking a look at all of this? Because this seems so basic compared to all the things that we've done up to this point. Well, think about it. This whole section of videos has been about really fine-tuning our understanding of object-oriented programming, starting with a solid foundation. You know, what are classes, what are class members, and then data members, and then looking at methods and properties. Well, now we're putting it all to use right now. So we have established our class, and now we've written, this is the program right here. This is the meat of it. It's really, really small. We're simply coming in here, and we're just creating an object, and then we're turning around with that object, and we're setting up a couple of things. And then while we continue running a loop, we simply tell the box to continue updating and continue drawing itself. We don't have to worry about if it's run into a wall, if it needs to change its direction and everything else. But that's irrelevant to us now. All of that has been coded, and we can forget about it. But because we are dealing with a console app, there's a couple more things we're going to need to do. So this is going to look kind of interesting when Logan runs this. So I just wanted to remind you, the reason we're doing something so simple is because we're putting everything together, and we're focusing on the whole idea of classes and the class members at a very low level with a very simplistic application. So Logan, let's go ahead and build real quick, make sure we have no problems.
All right. So can we build? Yes, we can still build.
So let's see what happens when we run it. Wow. Well, that happened real quick. Well, a couple of things are going on. First of all, we need to clear the screen before we draw an X. Go ahead and close that and run it one more time, just in case they didn't catch it. There you go. Ah, cool. So what's happening is, all right, go ahead and close that real quick. Let me jump back over to the board. Since everything else has been explained in the past, right, in older videos inside the XNA Xtreme class in Volume 1 in regards to like the bounce, collision, etc., we haven't really explained what's happening here. When we draw a character on the screen, we turn back around in the next loop, or the next iteration of the loop, and we tell it to update again, which is now going to, remember, in update, it's going to set our position and all that good stuff and get us ready to draw, which we turn around and draw. Now let's say it's drawn here. But what happens to the X that was drawn previously? It stays. So next time around, you're going to get this. Next time around, you're going to get this. And you're going to just get a whole stream of X's that run in this direction and then start bouncing upwards. And it's going to keep bouncing, and they're going to keep bouncing, keep bouncing. It's going to end up filling the entire screen with X's, and that is exactly what you saw happen. So what we need to do is every time we're ready to draw, we basically need to clear our console first. This will ensure us that our last one, so let's say that this was the last one right here. Well, we're ready to draw the next one. Let's erase the screen and then draw our next one. And this will make it look like our X is traveling around the screen. We'll do that, and that's going to get us 50% there. We're going to have another problem. Let's go ahead and show, though.
Okay. Let's jump back over now, and we now know that we want to completely clear the screen so that there's no old X's lying around when we want to draw a new one. So this can be a simple console.clear.
It's as simple as that. All right. Watch very close, and even then, I don't know how well this will pick up at 10 frames per second, but let's find out. Let's try it. All right. You may just see what just appears to be like random garbage, just X's that are just here, there, and everywhere. A little too fast, eh, Logan?
Yeah, very fast. There's actually nothing slowing this down, so it's redrawing and clearing as fast as humanly possible.
As fast as this machine can do it. So what needs to happen is we basically need to slow the system down after each time we draw or update and draw an X.
And this is the only part of the whole project that's going to be a little bit like magic. What we're going to do is tell the current thread to sleep for a specified amount of time. And the reason we're going to term this magic, more or less, is this is of no real concern once you get back into the worlds of timer-based windows or XNA that has a predefined or predetermined update interval. All of that has been set up, and if you want to adjust those controls, they're very straightforward.
Right.
In this case, we just have a raw console app, so we need to actually address this thread and tell it to slow down. So just write this down as the magic line for making a console app freeze for a specified amount of time.
We're just going to tell the thread to go to sleep.
And I'm also not going to add threading into the using, so I'm going to have to put out the fully qualified name for the namespace here. This is going to be system.threading.thread.sleep. And sleep takes in a specified amount of time in milliseconds. So we'll feed it 33 milliseconds for our timeout interval. And that way we'll get about 30 frames a second of actual update time.
Okay. Now if we go ahead and build and execute, there we go. Check it out. We have got the character X bouncing around a regular console screen.
And looking at it, I think I put too much of an offset on the bottom. Remember, I had to have the offset of 2 for the side?
Mm-hmm.
I think I also put that on the bottom. Back in box. Yeah, where Y is actually offset by 2. Sure. We'll set that to 1. And then that should look, that looks like it hits the bottom.
Looks a lot better. And yeah, so that's working out fantastic all the way around. All right, so now that we have got the class set up, instantiating the class is very easy.
While you're talking, I was just going to play around with this for a little bit.
Okay, well, go ahead and let them watch this. And
I'm trying to think. The 2 buffering might have been for an older version that had a character width of 2, or a different version instead of an X.
Gotcha. All right, let's go ahead and close this. Here's what I was getting at, though. Let's go back to program. We can get out of class. Class is a black box, if you will, and it has functionality and the ability to encapsulate state and all that just built inside of it. But that's the beauty of object-oriented programming. We're done with it. So now we can just come back over here. Watch how easy it is to add a second box into the mix.
Okay. Well, we know that this block of code effectively creates a box for us, so I'm going to copy and paste it. And then I'm simply going to change the variable name so we have a second variable. I'm going to call this box2 to hold a reference to a second box. And then simply change a few things, a few properties of this box. Let's change our velocity to 2 by 1 so that it's faster. And let's change its color to green so that it looks different. Let's change its color to green without caps lock being on so that it's a valid console color.
Now, of course, this does indeed instantiate the box class, but we're not calling upon it to update. So all we need to do is just copy and paste the 2 lines for box for updating and drawing and adjust the name.
So again, while we would have a second box, since we were never drawing it, we would have never seen it. So we'll simply copy our update and draw code for box 1 and add that for box 2.
Okay, let's go ahead and run it. And so now, check it out. We've got 2 X's that are bouncing around the screen. Hence the name, Bouncing X's. Simple object game. Well, not really an object game, simple object app. There we go. But again, the beauty is, in regards to what's going on inside the object itself, that's not our concern. And that's really nice here. I mean, and we've been taking advantage of that for a very long time now. With the console, when we say console.writeLine and we feed it some information to write out to the console, it's not our concern what's taking place inside the console.
I just had a thought. What if we, let's actually change the app a little bit. I was thinking, with the class being called box and the app being called bouncing X's, let's actually change box a little bit so that it's a more generally usable.
Okay.
Let's add a property for what character to draw.
Ooh, I like it.
That way you can have a box class, but use it in a game called bouncing X's.
I like it.
So we'll follow the same protocol we have thus far. We'll make a private field and then make a property to expose it. So we'll have a private char for the character. We'll just call this, I guess, character.
Character sounds fine.
And then we'll add a property for that so we can access it outside easily. So I'll just copy any one of the existing properties. So I can change this over to type char and give it a name of character. where we access the character field. And we're done with properties. We can close that back up. Now when we go to draw, instead of having this hard-coded X, we can actually put in character. Now that does mean back in program we need to specify a character to use for boxes, so we'll put box.character. We'll set this one to X. I'll set the other one to X as well. Oh, there
Just
we
to
go.
verify that everything does indeed run. And who are we missing?
Box.character 2.update. There, box
2
character is X. And there we go. See, and what's cool about that now is box can truly be viewed as, what is it? It's a bouncing box. Back in program, if suddenly the spec for the program changed to be bouncing Z's, it would now be very easy to change that without having to dig into the box class and change it. So now I've got an app called bouncing Z's instead of X's.
Exactly. I mean, we could do all sorts of stuff. You could give them health, and each time they hit a wall, you can subtract away from health. And once the health runs out, they go away. So those of you that are following along, just try stuff like that. Have a good time with it. Or every time it hits the wall, change the character. And there's all sorts of stuff you can do. The idea is just the concept of what's taking place right now. It really has been simplified in this example. I know it was a very simple example, but that's the idea, was just to demonstrate coming over here and defining a class. So we've got the class completely defined, and the class has made use of everything that we've talked about in this section. We've got a series of data members, and we've marked them all as private. We have got our series of properties, and these properties provide us access to our data members, so they're shielding the data members from the outside world. And then finally, we've got our behavior within the class itself, which are our methods: update, draw, and check wall collision. Then, from back over inside program, we wrote a very simple application that, in this particular case, generated 2 different boxes. And then we have a very simple game loop, and inside our game loop, what are we doing? Clearing the console and telling our boxes to update. But this is going to set us up for the next video. Think about how you would handle a scenario where I wanted to, say, hit a key on the keyboard, and all of a sudden it would just create a new bouncing box with a random direction. Or what if I wanted a loop that said drop 100 random boxes and have them all going in their own direction? We've got a problem, don't we? At the moment, we're going through here and we're instantiating the box class by hand every time. Now let's think for a second about if we were creating a game and you could have enemies randomly spawn in. As the level became more and more challenging, more and more enemies would spawn in. How would you write that? Would you code in all of the enemies that could be there, but then at a particular level say that that particular enemy is then in existence or visible? You wouldn't want to do that. I mean, you would not want to go and hand code every single enemy as we've hand coded these boxes right here. We'd want some way to be able to manage a whole lot of these objects. I mean, what if we were dealing with, flying through an asteroid field back in the Canon game, and we had hundreds or even thousands of asteroids? Are you going to, inside your game loop, tell 1,000 different asteroids that may be rotating to update and redraw themselves? You're going to have one of the most insane-looking loops you've ever seen, because you've got to scroll through thousands of lines, to find a particular area of code. So we need a way to handle, to work with, to manage a lot of these same type objects, okay? And that's, again, setting us up for the next video where we're going to talk about lists, and we're going to come back to our very simple bouncing X's application here and modify it in such a way that we can easily have tons of these X's bouncing around the screen. So with that, that's pretty much everything I wanted to say, Logan. Anything you would like to add?
No, I think that wraps it up.
Okay, so that is going to conclude this video on taking everything that we've looked at in this section and applying it to a very simple application. Thanks a lot.